plain-looking liquids, just sitting in glass jars. Nothing happening here. Or is there? Yes, something is happening. Silently, steadily, these liquids are giving off dangerous vapors, unseen except as their shadowy presence is betrayed by a trick of light. These vapors are the vapors of flammable liquids. A flame or even a spark can ignite them. The spark may be too brief for the eye to see, remote from the liquids themselves, yet every one of these liquids, now aflame, is used in industry. Many of them probably in your plant. These liquids may be used in their pure form, or they may be important ingredients in a large number of trade name liquids. The National Fire Protection Association lists more than 4,000 trade name liquids. While these are put on the market for a great variety of uses, they have one thing in common. They all have flammable or explosive characteristics, the outgrowth of the very properties that make them so useful throughout industry and commerce. For example, some of these flammables are used for their solvent power. They have potent properties for dissolving grease and for washing off cutting oils and chips. Others are used for thinning paints or lacquers. The binding agents applied in the assembly of plastic parts are usually flammable. So are many of the raw materials of which plastics are made. Flammables are used in laboratories for many purposes. They are even found in offices as liquids for duplicating machines, for instance. Some flammable liquids, such as the gasoline that powers industrial trucks, are actually used for their firepower. But whether their firepower is used or not, all of them have it. All of them give off vapors which will burn readily. These vapors are heavier than air. If they are not confined, they will crawl along the floors, invisible to the eye, creep down stairwells, descend into elevator shafts. Wherever they go, flammable vapors are an unseen hazard which in an instant can become the agents of disaster. Disaster that may begin like this. Or it may start like this. It could even begin when a tool drops to the floor and strikes a spark. Fire statistics state that each year, more than 50,000 buildings are destroyed or damaged by fire due to improper handling of flammable liquids. The annual cost, an estimated $50 million. A factory gutted by fire. There are few sights more desolate than the ruined machines, the destroyed materials, the charred reminders of jobs which no longer exist. To understand how such grim devastation can come about and how to prevent it requires some understanding of the nature of fire. Fire can happen only when three factors are present: fuel, oxygen or air, and there must be a source of ignition, ignition temperature. Only when these three elements come together can there be fire. Without fuel, there is nothing to burn. Without ignition temperature, fire cannot start. And removing oxygen snuffs out the fire. By working on the principle of breaking up the fire triangle, we can control the hazard of flammable liquids. The liquid and its vapors are the fuel leg of the fire triangle. To control fuel, we must contain the flammable liquid and seal in the vapors. Control starts with containment. But any container, any can or drum or storage tank needs at least one opening for getting the liquid in and for letting it out. This opening should be guarded by a self-closing cover, a reliable seal against spills, leaks, and evaporation. Thus, by effective containment of flammable liquids and their vapors, fuel is removed from the fire triangle. But heat from nearby production activities, hot weather, or a fire will cause the sealed vapors to expand. The expanding vapors will press against the walls of the container and might rupture it. This pressure must be automatically relieved. As soon as relief is achieved, the tight seal must be automatically restored. Conversely, when vapors condense because of cooling, a vacuum is created. A vacuum is also created when liquid is withdrawn. Due to the vacuum, atmospheric pressure might collapse the container. Therefore, an automatic vacuum relief must be provided to admit outside air. The container can then breathe. It can inhale as well as exhale. But the container is not yet entirely safe. For where there is an opening for fuel or air, flames too may enter. So provision must be made to arrest the flames at all openings. The principle of arresting a flame can be seen here. Burning gasoline is poured through a perforated metal plate into a beaker. We see that the flame is confined to the area above the plate, and that the gasoline below the plate does not burn. The perforated metal dissipates the heat of the flame above, and thus prevents the vapors below from being heated to their ignition temperature. The flame is arrested before it gets to the liquid. Actual designs of flame arrestors vary in response to service demands. One design is the combined dasher and fire baffle used in many types of bench cans and plunger cans. In another design, the perforated plate is rolled into a cylinder and threaded into the pouring spouts and receiving openings of safety cans, drums, and tanks. A third type is the multiple grid design used for flame arrestors on storage tanks. The many plates afford a large capacity of heat dissipation. Dissipating the heat of a flame before it can reach the fuel means that ignition temperature is effectively kept under control. Now, how about the third factor in the fire triangle, oxygen? We see here that by placing a cover over the flame, the fire is quickly extinguished because the supply of oxygen is cut off. This method of putting out a fire is applied to certain tanks which must be kept open for prolonged periods of time when in use. Such tanks are equipped with a fusible link. Should there be a fire, the fusible link melts, releasing the cover. The oxygen is cut off, the fire is extinguished. So you see how an understanding of fire provides the principles of safe containment of flammable liquids and their vapors. The engineering of these principles is the concern of the Protectoseal company. For many years, this company has been designing and manufacturing equipment to handle flammable liquids safely and economically, and at the same time help speed up production. The Protectoseal field organization consists of Flammables engineers who are specialists in setting up a sound program for handling flammables throughout the plant, from the time they arrive until the time they are disposed of. For example, dome covers for unloading railroad tank cars are especially designed to protect against fire or explosion during transfer operations. When properly fastened to the tank car, the cover permits all vapors from the liquid in the car to go through a flame arrestor. An inspection port, which also acts as an emergency vent, is part of the unit. And this is the opening through which the liquid is pumped into or out of the tank car. As flammable liquids are unloaded, the many types of tanks in which they are stored must be safeguarded during filling, withdrawing, sampling, and rodding. This is a cylindrical double-walled flame arrestor long enough to reach tank bottom. The the head assembly is screwed into position. With the rod lowered to the tank bottom within the flame arrestor, it is possible to take accurate readings without risking fire or explosion. Then there are the vents for pressure and vacuum relief. They also have flame arrestors. When the flame arrestor is located outside the vent housing, it simplifies maintenance. In addition, the flames are arrested before they reach the vent valves. There are many vents and vent fittings for many needs and applications. Steam-jacketed vents for tanks storing naphthalene and allied products. This 10-inch vent is one of a series of emergency vents used in conjunction with the normal operating vents. This is the 4-inch conservation vent and flame arrestor, another example demonstrating simplicity of construction and ease of inspection and maintenance. Many plants receive their flammable liquids in 55-gallon drums. Before liquid is taken from a drum, the ordinary bung cap should be replaced with one that will be safe in all circumstances. When this fitting is threaded into the drum, it provides the necessary safety devices. This cutaway shows that the fitting is equipped with 2 vents. This one relieves internal pressure. Another one admits outside air to relieve a vacuum. Here is the flame arrestor, and you see how it is threaded into the bung fitting. With this bung fitting, the drums are well protected, even against explosion of their contents should there be a fire in the storage room. This is a simulated storage room fire. The flames quickly heat the gasoline in the drum to the boiling point, creating a high explosive potential. Pressure inside the drum builds up rapidly and must be relieved. And there it is. The vent has opened. The pressure is being relieved. An explosion has been prevented. Although the venting vapors are ignited by the surrounding flames, the flame arrestor of the bung fitting keeps the fire from getting into the hot drum. Now, the fire under the drum and the fire at the bung fitting can be extinguished without the danger of an explosion. Important as Flammables engineering is in receiving and storage, its importance grows as the dispensing phase is planned. This drum is equipped with an end-of-drum bung fitting. One means of dispensing the liquid is the self-closing drum faucet. This faucet is equipped with a flexible hose, but it can also be obtained without the hose. The handle is spring-loaded, always making a leak-proof seal when not in use. A flame arrestor is located in the spout. The gasket is made of Teflon, a material which is impervious to all flammable solvents. After the faucet has been inserted, the drum is taken to the live storage area. It must be grounded immediately to protect against static electricity. A drip can is placed under the faucet to catch any liquid which may be spilled accidentally. On the drip can, note the perforated metal fire baffle, which is welded to the cover. The receiving container must also be grounded. As an extra precaution, the flexible hose should touch the opening of the receiving container. There must always be a good bond between nozzle and container. Another method, and incidentally the preferred method of transferring liquids, is by a hand transfer pump. This Protectoseal pump is easily installed. It provides automatic pressure and vacuum relief and is equipped with a flame arrestor. With this pump, approved by Underwriters Laboratories and Factory Mutual, no bung fitting is needed because all safety devices are incorporated in the pump. An important aspect of Flammables engineering is the selection of the proper container for the intended end use. For example, a safety dispenser can like this is used if the liquid is to be transferred to vessels or tanks which have small receiving openings. The flexible dispensing hose eliminates the need for a funnel. Since this dispenser can is a typical, well-engineered safety can, let's examine it more closely in cutaway. This can has two openings, one for filling, one for dispensing. The fill opening is kept liquid tight and vapor tight by a spring-loaded cover. A double-wall perforated metal flame arrestor protects the opening. The dispensing opening is sealed by a valve at the base of the pouring spout. This valve is operated by a spring-activated lever, separate from the carrying handle. Another type of double-wall flame arrestor protects this opening. The spring mounting on the fill opening is adjusted to provide pressure relief when needed. A concealed vacuum relief opening, activated by the dispensing lever, assures full, even flow when dispensing. And this is another safety can used to transfer liquids from storage to end use. This can is filled through its pouring opening, which also is protected by a flame arrestor. A spark sets fire to the escaping vapors, but the flame cannot heat the vapors inside the can to the ignition temperature because of the flame arrestor. Watch now how the self-closing cover snuffs out the flame. Because this can has a large pouring opening, it is very efficient when the end use of the liquid calls for filling larger vessels or tanks. Note that the can is returned to a safety storage cabinet. As much as 45 gallons of flammables may be stored at work locations through the use of these cabinets. Placed in strategic locations throughout the plant, the cabinets save many time-consuming trips to the central storage room. Safety storage cans and safety supply cans are available in great variety. They differ in size, shape, and design because they are adapted to many different liquids and to many different end uses. Let us look at some of these uses. First, washing and cleaning of machine parts to remove chips, shavings, grease, and cutting oils. One device for doing this is the automatic parts washer. The basket load of parts is lowered into the liquid and the air engine turned on. Since it is convenient to keep the container open, the cover is equipped with a fusible link, which works on the same principle as a fire sprinkler head. To see how it works, we have started a fire in the washer. As soon as the heat reaches 160 degrees, the link melts and the cover snaps closed, snuffing out the fire. The fusible link is easily replaced. The fusible link is an important safety feature of equipment used for washing and cleaning. Here again, the variety of equipment indicates the great helpfulness of Flammables engineering in planning the most effective use of solvents and other liquids. Another end use of flammable liquids can be found in certain assembly operations. Here in a plastic plant, for example, acetone is applied to bind plastic parts to each other. When the acetone is dispensed from Protectoseal plunger cans, fire and toxic hazards are held to a minimum. Only a measured amount of flammable liquid is drawn up to moisten the part or the applicating sponge. The bulk of the liquid within the can is protected by the fire baffle dasher. We can demonstrate this right here on the production line. Only the liquid remaining on the dasher burns. The heat cannot pass through the baffle to the vapors inside the can, and the fire goes out. Protectoseal has developed many kinds of applicating cans for many different needs. Several of these designs were developed to meet the specific problems of industry. For example, that was how a self-sealing toxic liquid can originated. This can seals in toxic vapors, except for the short moments when the plunger is depressed to admit fluid to the applicating brush. Maintenance of paint spraying equipment inherently involves flammables and can be costly and dangerous if proper equipment is not used. A safe maintenance device to keep paint from hardening in the spray gun nozzle is Protectoseal's Clean Safe Spray Gun Holder. When the gun is idle, its nozzle tip is immersed in a small quantity of solvent. This does away with the dangerous, costly cleaning of spray guns in open pails filled with flammable solvents. The holder is equipped with a fire baffle. The very small amount of liquid needed is supplied from a small overhead reservoir. With this equipment, the spray gun is always ready for instant use without the annoyance and delay of frequent cleaning. Flammable liquids in the form of fuels are used in virtually all plants. This operation of transferring gasoline into a material handling truck is protected in two ways: by the safety dispensing can and by the specially installed opening on the truck tank, which is equipped with a flame arrestor. But it is not enough to be careful with flammables when we use them. We must be equally careful in getting rid of them. Oily rags, paint wipers, and the many flammable wastes should be placed in self-closing disposal cans. Some of these stations also have dispensers holding a supply of clean wiping cloths or towels. Even old drums and pails can be put to good use in the disposal program. When the Protectoseal self-closing cover is attached to an empty drum, the drum is converted into a fire-safe waste receptacle. The cover may be left open for convenience, since it is protected by a fusible link. We have set fire to the drum. The link melts, and the fire is snuffed out. Disposal of waste flammable liquids need not be troublesome. This can is a safe intermediate container for receiving and storing waste liquids. The large opening is, of course, equipped with a flame arrestor, and the spring-loaded cap is designed to give automatic pressure relief. Yes, the handling of flammable liquids in industry requires the continued careful attention of management and worker alike, from the time the liquids arrive in the plant to when they leave it. To help in developing a productive as well as safe flammables engineering program, Protectoseal's field engineering service is available to any company, however specialized its needs, for a complete plant survey or for help with a special problem. Dictating his findings for the record, the Protectoseal engineer is concerned with every problem of flammables handling in every area: receiving and storage, production operations from machining through assembly and finishing, the maintenance shops, shipping, the laboratory, engineering and office. His recommendations are designed to achieve greater safety by preventing fire and controlling toxic vapors, and greater economy by conserving valuable liquids and speeding up operations. This program is backed up by Protectoseal's educational services, ranging from plant posters and training aids for the guidance of all personnel, to bulletins and technical data for production engineers and fire and safety supervisors. Through the years, there has been built up at Protectoseal a wealth of practical knowledge and know-how in applying the principles of flammables engineering to the problems of industry. If there is any part of this experience which may be of benefit to you, it is yours for the asking.